So, I mean, as usual, I'm happy to answer any questions as we go. Feel free to ask me, stop me with anything you have. I'm not going to cover who I am. I think everybody probably knows who I am by this point. I'm going to turn my clicker on, though. So we'll talk about users, Postgres roles, and creating and reviewing what exists. Talk about authentication, the different methods that are available, some information about how you can do what's called mapping users. And then we'll go over the grant system, the ACLs, and we'll talk a little bit about row-level security as well. So that's the plan for this talk. As mentioned, it's kind of cut down from a much longer training, so I'm going to be moving a little bit quickly because I've got 55 slides and 50 minutes. All right, so creating users is pretty straightforward. There's two main methods. You can either run this create user command. This is a Unix level command that you can run. This has to be run as someone who has the ability to create users in the database. Typically, that's going to be like your Postgres super user, which you can see here is Postgres@Bjorn. That's my Unix username on my my laptop, and running create user test1 creates a test1 user inside the database. The other approach that you can take is you can run PSQL and actually log into the database. You'll see here that when I've logged in with PSQL, I'm automatically logged in. We'll talk about why that is a little bit later, but some of the authentication methods will automatically log you in like this. You don't have to do anything special. And then this create user test2 creates a second user, and then I set a password for that user using the \password method. And as a super user, since that's who I am when I'm logged into the database, I can set passwords for other users. One other thing to note here is that this little hash symbol, if you're not familiar with it, in PSQL means that I am a super user. If that's actually a greater than sign, that means I'm a regular user. So something to be aware of. When it comes to user privileges in Postgres, there's a bunch of them that are actually defined at a per role basis. So this is a little bit of authorization inside of the role system that's more about authentication, but I did want to cover here since we're talking about roles. So the first one is super user access. It's something you don't really want to give out. Your application should never run as super user. If you have an application that says it needs to run as super user, find a different application or fix it because it's really not good and it's not safe. Create role is actually a bit more than it sounds. It actually allows both creation and modification of roles. So you want to be careful with that. It's not something I would typically give out either. The same thing with database, create database. Databases are a pretty big heavyweight object in Postgres. I don't really encourage people to give users access to create arbitrary databases because they are kind of larger things. Login is the big distinction between whether a user is a user or they're more like a group, right, or a role. So in Postgres we have roles, everything's a role, but you sometimes see things like talking about users or talking about groups. The only distinction between the two in Postgres is one has login rights, that's going to be a user, and one does not. That'll be what's considered a group. Login means that you're allowed to connect to any of the databases, right? Or you're at least allowed to try to connect to any of the databases. Databases themselves have connect privileges as well. We'll talk about that later. Replication means that you can log in as a user to do replication. So this is for users that are going to be doing like a base backup, right? If you wanted to do a PG base backup, that's a replication connection. If you wanted to do be a streaming replica, that's also something that would use a replication connection. Admin allows changing role memberships, and inherit allows automatically getting group privileges when you log in. So we'll talk about those in a minute as well. All right, so when it comes to roles in Postgres, users are roles are users, groups are roles too, right? You can use create role, which is just create user, no login. And then any role can be granted to any other role, right? This is a pretty big thing when it comes to what's considered RBAC, or role-based access control, right? Is this ability to say, I'm going to create this role, I'm going to grant it all of these rights, and then I'm going to grant that role to some other role, right? By default, inherit is set, which means that when you log in, you automatically get the group privileges of the roles that you've been granted. If you set no inherit, then you have a user that's kind of like a set role or a pseudo type of thing. And here's an example of what that looks like, right? So here I have creating a role with no inherit, and then I'm going to grant Postgres to that role, and then I'm going to create some user Joe, and I'm going to grant admin to Joe, right? So on login, Joe has the rights of Joe and admin, but not of Postgres, and that's because Joe is set to no inherit. Sorry, Joe is set to inherit, but admin is set to no inherit. Joe, however, is able to set role to Postgres. And when doing a set role, you actually also inherit the attributes, which means you get to become a super user too. We don't have any way currently to require a password for that set role. I know that's something that people ask for, and it's not something we have today. But I think maybe at some point we will. When it comes to reviewing roles, right, if you want to get a list of roles, that's \du. That also lists out the role privileges and attributes. You can also look at pgAuthID and pgAuth members. So let's look at what that looks like. So here's a \du, right, inside of PSQL, which gives you the role name, the attributes, and what member they are, what roles they are a member of, right? So here you can see I've got a very similar setup before. I have admin, which has no inherit and cannot log in, but they're a member of the Postgres role. And then I have sfrost down here, who is a member of both the admin role and the R1 role in this case. And here you can see R1 and R2 are roles, and they cannot log in. They're already following that? Yes?
R1 cannot log in?
R1 cannot log in.
How do we create that role, that group? That's a group, right?
So yes, you could consider that to be a group, and that would just be done, you just create that by doing create role R1. Right? So if you specify create role, it will create a role that cannot log in. Okay? If you specify create user, it will create a role that can log in. You remember, users are roles, roles are users, you know, groups are roles too. Like they're all roles, right? The what? So one of the things is that admin has no inherit set, right? Which means it won't automatically inherit anything. And otherwise, you know, you might have like, I'm not showing it in this example, but you know, where I would use this is I would grant access to the admin role for like probably select rights on a bunch of tables, so that when I log, you know, when I as Frost log in, I can see all the tables, but I can't modify anything until I set role to Postgres, right? That kind of an approach is what I would use. And now you can see here's what it looks like if you look at pgAuthID. Right? So pgAuthID actually shows a whole bunch of other stuff. Why? Because we have a whole bunch of what are called default roles. Okay? So here you can see Postgres is our super user, but then we also have, and I'll show that in a minute, but these are all the different, these are the super user, yeah, so there's true for that, and then inherit, create role, right? So this is how you can view what role attributes a role has, right? And I'll go over a bit more of the other columns as well. But these roles in here that we're looking at, PG monitor, PG read all settings, read all stats, right? These are the set of default roles that are available inside of Postgres to be granted out. Why do we have these default roles? To allow a super user to grant out access to things that previously could only be done by super user, and they don't fall into the more typical authorization system inside of Postgres. For example, PG read server files, right? This allows you to run a copy command on the Postgres server, right, and be able to copy whatever data off of disk that you want without having to be a super user. It used to be that that was restricted to super user. The same for write server files and execute server program. Now, you still have to be really, really careful with these because someone could actually get themselves access to super user if they wanted to, especially if they can execute server programs, right? Because when they execute a server program or when they read a server file or write a server file, they're doing it as the database user, right? As the user that the database runs as. So that's something to be watching out for. PG signal backend, on the other hand, is actually really handy and basically means that you can signal other backends to tell them to cancel queries or to tell them to terminate. Right, so that's something you might grant out to an admin so that they can go and kill off application processes that have gone wrong or something like that. right? So that's something that's handy. One thing to note is that even with PG Signal backend, a non-super user can't send a signal to a super user's backend, right? So there is that additional caveat. PG Monitor is granted the PG read all stats, PG stat scan tables roles. And the reason for that is that PG Monitor is actually a role that you would typically grant out to, say, Nagios or Ichinga or Prometheus or PG Monitor or whatever role is logging in for these different tools to be able to monitor the database, right? And this gives you the information that you need to be able to do monitoring of the database in a deeper way than a regular user is able to. So that's something that can be pretty handy. So particularly being able to read all of the stats from all of the tables, right? To be able to collect up all of that information, right? You can do that with that PG Monitor role. Or you can grant that out explicitly, just PG read all stats. PG stat scan tables is used for some of our tools that allow you to do things like PG stat tuple, right? And go read the entire table and say, okay, give me the amount of bloat in this table kind of thing, right? The reason that that's a separate privilege is because scanning a table obviously involves pulling it into memory, right? And it might blow out your cache or do other things that maybe you don't want. But that's kind of a quick rundown of all of the different default roles that we have. So these are just, so here across the top I have role super, inherit, create role, create DB, and can login. And then we also have replication, bypass ROS. So bypass ROS basically means that you can query a table without going through row-level security. We'll talk more about row-level security later, but that's what that role attribute's about. And then role connection limit is how many concurrent connections a user can have. And then we have, yes?
PG stat scan tables, it is only for the block level reads and does not mean the user would have access to the data.
Right, that's correct.
They cannot still read what is the data values inside here.
No, they can't, although
Estimate the scan,
yeah, they can just get information about the size. I will caveat that a little bit though, because I mean that's true for PG scan, PG stat scan tables. PG read all stats gives you access to read the statistics tables, and those do have things like MCVs in them. So whether or not that's a concern for you is up to you, but it does give them a little bit more access to the actual data.
and reads all stats would also give me ability to read the catalog, or there is no such privilege separately for catalog access, right?
Typically, catalog access is pretty open. I mean, all the PG class and PG attribute and all of those tables you can just read. You don't need those are granted to public for reading. There has been discussion at in the past about implementing RLS on the catalog tables, but there's been a lot of concern around that too, and it hasn't happened. So, so then we also have role password and role valid until. So role password, if you actually have access to read PG auth ID, this is why you might not, right? You have to be a super user to read this particular table because it's going to have this password information in it. And then role valid until is how long the role is valid for. We then have PG auth members. So this is the underlying mapping between roles and their memberships, right? So basically, you have a role ID and then they're a member of something, right? And these two columns are OID columns, right? So the OID is something that I probably should have shown here. You can select the OID from out of PG auth ID, right? And this is going to be like role 3374 is a member of role 3373. And that membership was granted by role 10, which you can probably guess is the super user. And then admin option here specifies whether or not that role is allowed to then grant that role to some other role, right? That's what the admin option is all about. All right, so let's talk about PGHBA configuration. So we talked a lot about roles. Now, how do we actually get people authenticated into the database system? So this is how that works, is we have PGHBA. It is read from top to bottom, and each record is basically whichever one matches first wins, right? So local means it's a local UNIX socket connection. Host or host SSL or host no SSL are all for TCP-based connections, and SSL versus no SSL is whether it's got encrypted or not. The host line would match either an encrypted or an unencrypted connection. You then, once you've got a match on that, you can then say, okay, well, I want to match on a particular database or on a particular user, and then even specific IP addresses, right, which can be either v4 or v6. And then once we've got all of these things matching, right, once we're scanning through the file and we found a match, then we get a method, right? We're going to talk about the different methods that Postgres offers in a minute, but that's essentially the way that the user is then authenticated. Note that there are some special databases and special users here that you can use for kind of catch-all or wildcards, or for things like membership. So when it comes to those methods that we're talking about, the ones that I recommend are peer, GSS, and certificate-based, right? And that's because those are strong authentication mechanisms that are secure for both the client and the server, right? So peer, for example, is only works on Unix sockets and just basically passes through the Unix user, right? So when you saw me run PSQL and log in directly as a as a super user, that's because there was a PGHBA line that said local peer, right? And the Postgres user, Unix user, is who I was, and when I logged into the database, that meant I was the Postgres database user automatically, right? And that user is a super user in the database, right? So that's peer-based authentication. GSS is also is basically Kerberos. SSPI is basically Kerberos for Windows. So this is for integrating in with an MIT or Heimdall Kerberos environment or with Active Directory, right? So this is something I strongly recommend if you are already running in an Active Directory environment. This is what you should be using, right? And it's a very strong security mechanism. There's a lot of documentation about it, but it basically means that like the user's password is never seen by the server, right? The server's credentials are never seen by the user, right? And it has some other nice guarantees inside of it, and it's been very, very widely deployed. And it's actually the basis for authentication inside of Active Directory itself. So whenever you're using Active Directory, you're logging onto a Windows server, or you've joined your Unix server to the Windows domain, all of that is through Active Directory, and it all uses Kerberos. Certificate-based authentication is for client-side certificates. So if you have a public key infrastructure, right, you have a PKI that you've set up where you have your CN, and you can grant out certificates off of that CN, you can use client-side certificates. So this is also very strong, right? The client has a certificate and a private key. The server has a certificate and a private key. They're both signed by a trusted third party that is the certificate authority, right? And you can prove all of that, right, provided that you have all of the right pieces in the right places. And that makes it very secure. And again, the server doesn't see any of the user's private information, and the user doesn't see any of the server's private information, right? The private keys are protected in those cases. So you don't have to worry about the server being compromised or the client being compromised, right? And that's a really good approach to dealing with security over the internet. There are some other methods that I think that are okay, but they're not ideal, right? Scram is actually pretty good. So Scram is based on an RFC, Salted Challenge Response Authentication method. It's password-based, but it's pretty strong otherwise. I don't really like it because it's password-based, but it's actually pretty good. And the way that it does the challenge response also avoids the client sharing any information with the server that it shouldn't, and the server the server doesn't share information that it shouldn't with the client. So it's pretty good in that regard. Unfortunately, it's password-based. So that's the one thing I don't really care for it. I much prefer strong keys, like what you get from Kerberos tickets or from certificates. Then there are the other ones, right? So PAM isn't really ideal. It's actually pretty awkward to work with. And when you're doing PAM or radius or password, your password is sent to the server, right? And that's typically not a good thing because that means you're sharing your secret with the server. So you have to trust that that server is not compromised. And that is, a risk that you end up taking with those methods. So that's part of the reason why I don't really care for them. The good one is like radius, for example, includes a one-time token typically. So it's got a PIN, but it also has a one-time token. So in the event that the server is compromised, it's at least less likely that that server is able to then, that the attacker who's compromised the server can then log in as you somewhere else, right? But they would still have your PIN, so that's unfortunate. Obviously with PAM, radius, and password, you do want to use SSL for network security as well, just to make sure that because you're sharing this secret with the server, you don't want anybody like on the wire listening in to be able to see it. So, maybe you're okay with the risk that the server gets compromised, but you don't want the risk that your network connection is compromised. So methods that I really don't like. MD5, which is the old method, this is the pre-Scram days. I don't like it because it's deprecated and you should use Scram, right? Scram is much better. I don't really care for LDAP. LDAP is another one where your password gets sent from the client to the server. The thing that puts LDAP into this other category is that it's almost always used when you're in an Active Directory environment and you should be using Kerberos, right? Or GSS API. And so that's one of the reasons why I don't care for it. IDENT, IDENT is just completely unsecure. It wants to be like a network-based peer, but it doesn't work at all. There's no security there at all. It's also been deprecated. And then trust is essentially just bypassing all authentication. So there are some very specific use cases where you might use trust, but I don't typically like it. I would rather use peer if you're in an environment like that. So those are all the different authentication methods that Postgres supports. Now let's talk about mapping users. So when you have an authentication method such as Kerberos or say client-side certificates, you often have a username in the authentication system that maybe you don't really like or want to use, right, inside of the database. And so Postgres gives you an ability to map them. So for example, in Kerberos, your principal would look like this, like sfrost@snowman.net. It's that whole long thing. And maybe you don't want your user in the database to be named sfrost@snowman.net, right? You'd rather it be named like sfrost or something shorter. So this mapping system allows you to do that mapping. And in fact, it also supports regular expressions here. So you can see this last one here is just basically stripping the realm off, right? As long as the realm is snowman.net, I'm going to strip it off. And then users can log in as just their base username into the database. But here you can see I've also got a mapping, an explicit one for sfrost@snowman.net to let me log in directly as Postgres. Not necessarily something you want to let everybody do, but proves a good example. When you're setting this up, yes?
So how does it link there?
So how does what?
sfrost@snowman.net matches to identification mapping, right?
It does. So what happens, so the way that it picks is it picks based on what user you're trying to log into the database as.
Okay.
Right? So it's going to be based off of both, so like if I want to log in as Postgres, I have to tell the server that ahead of time, and then I'll log in as Postgres under the first line. And if I'm trying to log in as a different user, that'll match the second line potentially, right?
So basically, PG identity is really just a mapping of the user. It is not an authentication method.
It is a mapping, that's correct. It's not an authentication method.
It could be peer, which is like picking up the
Right. Yeah, and the way you specify the mapping is you have to specify on the PGHBA line, you have to say map equal whatever you want the mapping to be, whatever mapping you want to use. And that can go on any line in the HBA.conf for any method. So you can use it with peer, you can use it with Kerberos, you can use it with certificates or LDAP or whatever. All right, let's start talking about permissions. So in Postgres you have, this is all under the kind of authorization side of things now. So we've moved away from authentication, we're done with that. Now we're going to talk about authorization. So in Postgres you have grant and revoke commands. that you can use. And by default, like the public schema, for example, allows any user to create objects. That's one of the big problems that Postgres has. So I strongly recommend people revoke create on that public schema, because otherwise anybody can create objects, including functions and types and other stuff that you don't necessarily want them to. I do recommend using per user schemas typically. If you've got a lot of different users on your environment, I like setting up per user schemas and then letting users create objects inside of those schemas. Almost everything in Postgres has some set of permissions. What those are varies depending on the object. So here are some common ones. Right? I'm not going to go over all of these, but you have databases, have these, and schemas, and tables, and views. One thing that's interesting is views are automatically updatable. Simple views, right, what are considered simple views, are automatically updatable inside of Postgres. So that means if you grant update permissions on a simple view, a user can issue an update against that view, and it'll actually update the table underneath, even if they don't have access to that table. Right? That's how the view system works. The same is true for select, right? If you have create a view and you grant select rights on the view to someone, they can select against that view even if they don't have access to the tables underneath. The user that needs to have access to the tables underneath is actually the view owner, right? So whoever owns the view that's the access privilege that's used to check if that table can be accessed. Also, columns, for example, don't have update privileges, or sorry, delete privileges. That's because you kind of have to delete an entire row at a time. You can't just delete an individual column in Postgres. One thing that you want to watch out for also, functions can be security definer. And what that means is that they're basically set UID. So if you have it be security definer, that means the function runs as the owner of the function, rather than running as the user calling the function. So let's talk a little bit about the default permissions, right? So generally, Postgres is secure by default. The big exception to this is execute, right, for functions. So functions automatically have execute privileges granted to public as soon as they're created. Owners have rights on all of their objects, and membership in an owning role implies ownership, right? It means ownership. So if you're a member of the admin role and the admin role owns some object, then you are considered to also be an owner of whatever that object is. One thing to note about functions here, when we were talking about security definer functions before, that's where it gets particularly dangerous that execute is granted by default. The way to address that is to create your function in a transaction, and then after you've created it in that transaction, in that same transaction, revoke public execute privileges, right? And then commit. And that way the function will only ever exist with that privilege revoked. We also have default privileges, which you can set for roles. So you can say when Bob creates an object in this schema, automatically grant select access to admin, for example, right? It is applied to a role. It can't be applied to just a schema. And then whatever new objects for the type of object being created, because you can have default privileges for different types of objects. Those will be applied. There is also grant on all in a given schema. So this is a convenience command, really, for just issuing a whole bunch of grants. And you can specify whether you want it to be done on tables, views, sequences, or function. But this is a one-time operation, right? New tables and new objects won't get these, right? So you can go and do just kind of a global grant all. But if you want something that persists, you're going to need to go set up alter privileges. You're going to have to go set up default privileges, I should say. Does that make sense? Yeah.
If you want to drop a user who owns some objects, so we need to first drop the objects.
Yes. Yeah, you would need to drop the objects first. You can, I mean, there's a cascade option, but I wouldn't recommend it.
So we need to change the ownership of the objects or something.
You would want to change the ownership, yeah. Which is one of the reasons why I tend to like it when all the objects in the system are owned by appropriate roles, so that you can go drop a user and it's not an issue, right? It's much better to set things up that way so that you don't have to go run around and change ownership of objects. So you cannot, so every object has only one owner, but anyone who is a member of that role that owns the object is like an owner. But every object actually only has one owner. Okay?
So that will not have to be changed before dropping that.
Yes, you would want to change that owner before dropping that role. Yes.
But isn't that the case that if a particular object has one owner, it's more of a role, right? And if somebody else is also assigned a member of that particular role, then even if you drop that object, then automatically it should be taken care of.
I'm not sure I followed the question. I think what you're asking is if I have a role that owns an object, and I have two different people who are members of that role, yes, you can revoke one membership out of that role just fine, or drop one of those roles. You just can't drop the role that actually owns the object. Yeah. That's where you run into Postgres will complain at you and say, don't do this, right? And then you can go alter the ownership of that, and then you can drop it.
You can also have a role which does not have any members owning a particular object.
Yes, you can have a role that doesn't have any members owning an object, yes. One other fun thing is that roles are shared, right? They're shared at a catalog level, so they're actually shared across different databases. So if you go to drop a role, you can sometimes end up with cases where Postgres will tell you, I can't drop this role because it owns object in another database, right? And then you got to go connect to that other database and go alter the ownership of that role. It's one of the reasons why I'm not a big fan of having a lot of different databases inside of one Postgres cluster. But that's a whole nother talk. What about schema? What would you like to know?
How does the schema works in Postgres? Because
So schemas have two privileges. They have usage rights and create rights. You have to have usage rights on the schema in order to be able to access the objects inside it. Okay? And then you have to have create rights in order to be able to create objects. Yes?
When you, just like functions, when you create a database,
Yes.
they automatically have connect right to public.
Yes, that's true. So databases also have a connect privilege, and that is granted to public by default as well. So if you wanted to manage connection access to a particular database, you would do that by first revoking connect privileges from public on that database, and then granting them back out to the individuals that you want to allow to connect to that database.
Or before you create the database, make sure that you have a proper pgCHPA entry.
Yes, you could also use,
A case when someone before you
Right.
revoke the permission, someone
right, you can also manage it with pgHPA instead, yes. All right, so let's talk a little bit about like viewing of these ACLs. So these are all the different ways to look at ACLs in PSQL, and in fact, there's a whole bunch more. The particular ones that I want to highlight here are \DDP. That's going to give you a list of the default privileges, and then \DN plus. That gives you a list of the schema's privileges, and then \DP, which gives you a list of the privileges for tables and other regular objects. So here's what that looks like. Looks like a bunch of gobbledygook, doesn't it? This is what it looks like when you do \DP in PSQL. It's also what it looks like if you query the database on one of the on the columns that are associated with access privilege in the catalog. You're going to get this weird gobbledygook, right? Well, what this means is that sfrost here, for example, has all of those privileges. Privileges are represented by a character at a time, and that privilege was granted by the sfrost user, right? Does that make sense? And then here we have another privilege at a table level for this particular claims table, and this is role 1 has been granted by sfrost that set of privileges. I'm going to talk about what those individual letters mean in a minute. And then we also have column privileges. So Nebo account ID is in the claims table, right, as a column, and R2 is granted select access, that's what R means, by sfrost on that column. Everybody kind of following how that works? So this is what the actual kind of meaning is for each thing. And I'm going to talk a little bit here about what these are. So there's a little bit of a mnemonic, right, around these things. It's not always great, but we try. So A means append, right? That's actually what it was way back in like Postgres 95 or something, even earlier possibly, before we changed it to be SQL. And that means insert, right? Append, insert, kind of goes together. R meant read, and now that means select. W means write, which is actually update. And then D means delete. Okay, that one's pretty straightforward. We then have capital D, which is like super delete, right? And that's for truncate. X is references, because it's kind of like a cross-reference, right? That references is for like foreign keys, right? If I wanted to have a foreign key between my table and the other table, I need to have reference access to whatever columns on the other side I'm trying to include in my foreign key. T is for trigger. Capital X is for execute, right? This is something you see on functions. And then we have U, capital U, for usage. And you can see that there's a whole bunch of things that have usage rights associated with them, schemas and foreign data wrappers and servers. Capital C means create, and that's for databases, schemas, and table spaces. Capital T means temporary, so that's for creating temporary objects in that database. And then C means connect. That's pretty straightforward. So these are all the different ACLs that Postgres has and the objects which you can grant them on. Any questions about that? All right, I'm going to jump into row-level security. I might go a little bit over time, but I know we have a break or something after this, right? All right, so what is row-level security? So row-level security allows the ability to filter records that are actually returned based on some kind of policy or criteria, based on the user that's asking the question. So you can have a situation where different users have different viewpoints, different views of the database, right? So other databases, I've called this things like VPD, for example, but in Postgres we refer to it as row-level security, and we talk about it in terms of policies. We also can limit the ability for what's allowed to be updated by a user for a given table, or even what the result of that update is allowed to be inside of Postgres, right? One of the other points about RLS is that it requires policies to always be applied, right? What that means is that if there aren't any policies on a table, we have a default deny policy that's automatically applied. So how do you set up row-level security? So you just say alter table, and then you say enable row-level security. And that will enable row-level security for that table. And then once that's done, all access to the table has to be through a policy because of that default deny. This does exclude the super user and the table owner, right? The super user bypasses pretty much everything. The table owner is the user that can change the policies, so they are also excluded. When you go and disable row-level security, it does disable RLS. The policies on it are no longer used, but it doesn't actually remove those policies, right? The policies are still there attached to the table. They're just no longer being enforced. There is also a force mode, and basically all that does is apply row-level security to the table owner, but the table owner can go turn that off too. So it's not, it isn't actually something that provides any kind of protection for the data. It's more around like if you're a table owner setting up policies and you want to test stuff, right? That's what that's really for. There are a couple options that any user can set, which is row security. On means normal mode, everything, the row-level security policies get applied. Off basically says don't ever apply row-level security, and instead what will happen is an error will get thrown, right? And this is basically added in for two main reasons. Reason number one is for things like pgdump, right? You may, if you're using pgdump for your backups, you don't want row-level security to be applied, and so pgdump by default sets row security to off. There's an option to disable that, right? You can have it not set that and then get potentially a subset of the data. But basically we did that because pgdump is considered to be a backup tool, and so it made sense to us to make sure that it errors out if it's not able to get all the data. The other case that you may want to set this is if you're a super user and you're querying tables. Because the policies themselves can end up running, they can include functions that would run in security invoker mode, which means that they would run as the caller. And so you wouldn't want that to happen if you're a super user running on a potentially compromised system. You'd want to turn row security off. So for creating a policy, it's pretty straightforward. There's this create policy command that we have, and you define it on a particular table, right? And then you can specify what type of command you want it to apply to, whether you want it to apply to all commands or just selects or inserts or updates or deletes. And then you can specify a set of roles for that policy to apply to. And then you have these two expressions down here. You have a using expression. That tells you what rows are going to be visible through this policy. And you have a with check expression that says which rows, or what are the valid values of rows that can go back into the table after an insert or an update. So that's a really kind of important key thing, because it means that people can't do things. It means you can set things such that people can't like they can see certain rows, but if they go to try to update them, if they change one of the values in one of the columns to an inappropriate value, they'll get an error back, right? So it allows for much more granularity when it comes to building security into the database itself. If you don't specify a with check clause, it will use whatever the using clause is by default, but that is not required. You can also specify, if you don't specify roles, it's public by default, which means it applies to all roles. So here's like a really, really simple example of a policy being created, right? And this basically is saying, okay, for this table, my table, I'm going to create this policy named P1, and it just says that the column my user must equal current user. So if I go and query this table, right, as sfrost, only rows where my user is set to sfrost will be returned. If I try to update this table and change that my user column to be something other than sfrost, Postgres will throw an error. Right? If I try to insert a row into that table where I specify my user as some other user, not sfrost, Postgres will throw an error. Right? Those are policy violations under row-level security. So keeping with that same theme, let's talk about some of the defaults, right? So these two policies are identical, right? All I'm doing is I'm just being explicit here with the with check clause. Same here, right? This is still the exact same policy. I'm just being explicit about saying this is for all roles. Sorry, for all commands. Sorry, that's for all commands, and then to public means it's for all roles, I should say. So this, again, is the same command. I'm just being explicit about that this is to public or to all roles. So if you wanted to apply a policy that was only for select queries, right, you would specify for select here. But this, because it's a select policy, only allows the using clause. You can't have a with check clause here because it's not appropriate. Similar thing for insert, right? For insert policies, if you want to specify a policy for insert, you only have a with check clause. Update allows you to do both, which is one of the kind of fun things. So with update, you can actually specify two policies, a using clause and a with check clause. And then delete only allows a using clause because it's only for visibility. That should say for delete there, so I got a bug in my slide. All right, so then you can also alter policies. So altering policies is pretty straightforward. You can change the policy definition. You can change what sets of roles the policy applies to. You cannot change the command that the policy is for, right? In that case, you have to drop and recreate the policy. And that's because the current set of using and with check clauses might not make sense for whatever command you're trying to change from or to. And then you can also rename policies. That's pretty straightforward. So these are just some examples of altering policies. Nothing too special there. Then you can drop policies. And again, just a reminder that when you drop the policies, if you drop all of them, then whatever then the default deny policy will be used. And that's true if there are no policies that apply to a given user, right? So if you have like policies that are defined for R1, but you don't have any policies for R2, and R2 tries to access the table, they'll just see an empty table, right? Assuming that they have access. And let's talk about that a little bit, right? So here's how the policy and grant systems kind of interact, right? So the grant system here is table level and column level, and it's kind of all or nothing, right? And you typically would use views to limit the data. But with the policy system, you can do table level row selection, right? And it's just basically a conditional that gets added to the queries. And then we get errors back for any rows that you attempt to add which violate the policy. And note that you have to have both, okay? And in fact, in Postgres, we enforce that you have to have both. So if you're a user R, even if there's a policy on the table saying that you can view some set of rows, you can't view anything unless you also have been granted select rights, right? You have to have both. You have to be granted select rights for the table, and then you also have to have a policy that applies to you if row level security is enabled for that table. So here's a really simple kind of example of what it looks like to have a policy, right? So this is that policy I was doing before, where you have this policy P1 with that expression, right? And then here you can see as a super user, I see that there are these 3 rows, but then when I go to actually set role and look at the data, I only see that 1 row. And then here's an example where you can see if I try to insert data for somebody else, I get an error back. See, I know I'm kind of running out of time here. So this is just an example of setting with check. So you can see I'm inserting the data, even though because the with check is set to true. And then we have, we also have the ability to have external policy systems. So here's an example where you can say, okay, if I have a SE Linux policy function called check SE Linux, I can call out to that, right, as part of my expression. And then that will get called for every row, and it'll basically return true or false and specify whether or not a user is allowed to have access to a particular row in the database system. So here's I'm just going to kind of go quickly through this because I'm just about out of time, but here's the Unix password file done as a table with row level security on it, right? So here, the regular Unix password file, username, password, UID, GID, et cetera, and then I got these 3 users. I have an administrator, and then I have Bob and Alice. So I'm going to populate the table initially with data for these 3 users, right? So admin has this, and Bob has that, and whatnot. And then I'm going to enable row level security. Then I'm going to create these policies, okay? I'm going to say the admin has access to all the rows and can do anything on it, on all of them, right? And then I'm going to say, okay, all users are allowed to view the view the rows, right? And then I'm going to say, okay, normal users can update their own records, but only if they follow this requirement to use these particular shells. So here you can see I have a using clause where current user equals uname, right? So that means that when a user goes to do an update, they're only going to be able to update rows that match their username. And then I'm going to say with check where, okay, current user and uname have to be equivalent still. They can't have changed that. And the shell must be in this list of shells, right? And then I'm going to use grant to actually grant access. So select, insert, update, delete are granted to admin. And then users get select access, but only on the public columns, right? The public columns being the username, UID, GID, real name, home phone, home dir, and shell. And then I'm going to grant update on the other columns. Password, for example, users can update real name, home phone, and shell. So let's look at what this does, right? So as an admin, I can see everything, right? If I set role to Alice, though, and I try to just look at all of the rows, I get a permission denied. That's because there are columns in there that Alice doesn't have access to. So if Alice wants to read from the table, she has to select out a specific set of columns that she does have access to. And here you can see that she does that, and she can see the public columns. All right, so now, as Alice, I'm going to try to update the password and change the username to Joe. Well, I can't do that, right? That's not allowed. Okay, well, I'm going to change my real name. Note that this update clause did not include a where clause, right? Why is that? Because we don't need one, The only rows that are visible to the update statement are the rows where Alice is the user, right? So if I try to set name and include a where clause, right, that matches somebody else, I'm going to get back an update 0 because there were no rows that matched somebody else in my view of what's allowed to be updated. And if I try to update the shell to set it to something else, I also get a with check violation. Same with delete, like Alice was never granted delete rights on this table. And Alice is also not allowed to insert into this table. But Alice is allowed to change her own password. Not that I would ever recommend setting clear text passwords in a database, but this is just an example. Does that all kind of make sense? All right, so real quick, I'm going to talk about leak-proof functions. So leak-proof functions are really important when it comes to row-level security because they're allowed to be pushed down below the row-level security policies, right? And what that means is that leak-proof functions can see data that the user should not be able to see. If those functions ever return an error that includes data, because it found some data underneath, that data should not be visible to the user, right? And so this is why we call these functions leak-proof, because to be leak-proof, you cannot leak any data, and that means that even in error conditions, you cannot be reporting back any errors that include data, right? If you are, then you're not leak-proof. But this is really important because with leak-proof functions, we're able to effectively use indexes. Because basically, almost all of the B-tree operators, right, are leak-proof, right? We've reviewed them and made sure of that. And what that means is that they can be pushed down underneath of the row-level security policy. So the row-level security policy may say, you know, you have access to like all the rows that are listed as orange, right? Well, there could be, you know, millions of those. Right? If lots of the data is orange, and there could be lots and lots of those. What you want is you want it so that when the user actually queries the table and says, well, I want rows where, you know, age is over 10, right? Well, if that's selective in that data set, then we want to be able to use an index, right? And so the greater than operator is leak-proof for B-trees, and that means that we can push that greater than down below the test for orange, and we can make sure that we still are respecting the row-level security policies while also being performant. So I have an example here, but I'm afraid we're probably running pretty low on time, so I think I'm just going to kind of click through it real quick. Is the coffee here? Okay, well, I can't compete with the coffee. Any quick questions?